Good morning. I'm Nirupam and my topic is pulse code modulation. Here consider the analog signal x of t. This signal is first sampled at a definite interval of time. These samples are held for this definite interval of time, or we can say regular interval of time. These are the quantization levels which corresponds to unique combination of bits. The analog signal is transmitted or stored as a stream of bits and reconstructed when required. This quantization, these are assigned a value near to the quantization level. Like this sample is assigned value 2, which is in binary 1 0 for this particular interval of time. This 1 0 value is hold. This is again an original signal. This shows the quantized signal. Apparently, it is clear that the original signal and quantized signal are not the same. However, if we increase these number of quantization levels, the quantization error will be reduced. Now the question arises, what is the quantization error? Actually, the gap between the original signal and the quantized signal is known as quantization error. Here this is the quantization error. Here again this is the quantization error. So if we will increase the number of levels, the quantization error will be reduced. Like here. Now we will see PCM of a speech signals. As we know, the speech signals are contained in the range 300 to 3400 Hz. So Nyquist rate becomes 6.8 kHz, but practical sampling rate is 8 kHz because it is always advisable to take sampling rate greater than the Nyquist rate. Number of quantization levels is taken as 256, hence number of bits per sample is 8, as it is clear from log 2 256 number of levels, and data rate is n into fs, hence 64 kilobits per second, and bandwidth required is half nfs, that is 32 kilohertz. PCM based TDM systems. T1 carrier system is still in use today in US and Japan. A similar scheme called the E1 is used in Europe and Pakistan. These schemes are used to multiplex the speech from multiple subscribers and transmit them to their destinations over a common time shared channel. Hence the name time division multiplexing, that is TDM. Sampling rate used for voice is 8,000 samples per second. Hence sampling interval is equal to 1 by f is equal to 125 microsecond. This means that time between two consecutive samples is 125 microsecond. In T1 systems, the signals from 120 signals from 24 channels are taken. These are this is channel number 1, this is channel number 24, and from each channel a sample is taken. After 24th channel, again the turn for channel number 1 comes. The channel number 1 to 24 24 sample number 1 is contained in 125 microsecond only. Every sample is represented by one of the 256 quantization levels that is closest to it. This corresponds to 8 bits to transmit one sample. Hence, the channel number one sample number 1 is contained in these 8 bits. Data rate of one voice channel is equal to 8 into 8000 is equal to 64 kilobits per second, where 8000 is 8000 samples per second and every sample is represented by 8 bits. Hence it is N and this is Fs, hence NFS is 64 kilobits per second. In T1 system, 24 channels are multiplexed in time, so data rate of T1 stream becomes 1.536 megabits per second, but the actual data rate is 1.544 megabits per second. The extra 8000 bits per second result from the overhead bits which are inserted along with the data. A segment containing one code word corresponding to one sample from each of the 24 channels is called a frame. Hence, each frame has 24 into 8 is equal to 192 data bits and takes 125 microsecond. At the receiver, it is also necessary to know where a frame starts in order to separate informations correctly. For this purpose, a framing bit is added at the beginning of each frame. Therefore, total number of bits per frame becomes 193 because 192 data bits are in each frame and there a framing bit is added. Hence, total number of bits per frame becomes now 192. 192 plus 1 is equal to 193. Along with, along with voice data, frames should also contain framing bits and signaling bits. Framing bits indicate a start of frames, while signaling bits contain control information such as routing information, on hook, off hook signals, alarm signals, etc. Here it is T1 frame format, which is a older scheme. Frame 1, frame 2, frame 3 up to frame 9 are shown. Uh, one framing bit at a start of each frame and 7 bits to represent each sample. Now this is the old T1 scheme and is now obsolete. One bit, one bit in each channel reserved for signaling. This means a total of 24 bits per frame for signaling. Because each frame contains 24 channels and in each channel the bit number 8 is used for signaling, hence 24 bits per frame for signaling. T1 newer version has some modifications. In the newer version, signaling bits are included in every sixth frame. This is done by replacing the LSB of every sample by a signaling bit. Some amount of information in every sixth sample is sacrificed for signaling. However, since only the LSB is removed, there is no noticeable loss in voice quality. These frame 1 and frame 7 means after every sixth frame, the signaling information is contained. These blue frames shows the frames which has signaling informations. These are LSBs of frame number 1, frame number 7, frame number 13 means after every sixth frame. All other frames use 8 bits per sample. This technique in which signaling information is sent in every sixth frame is called robbed bit signaling. Thank you.